Hello everyone. Today in this lecture we are going to talk about how to write down thermochemical equations for the formation of covalent compound using Hess's law. Now there's a lot of information that we will discuss and we will learn in this lecture. For example, we will learn what is a thermochemical equation. We will learn what is a Hess's law, how to write down different thermochemical equations for the formation of covalent compounds, and finally we will apply Hess's law on the thermochemical equations to get a formula for doing numerical problems. So let's start with Hess's law. What is Hess's law? What is the important information that we must have in our mind whenever we want to write down thermochemical equations for the formation of covalent compound? So as far as Hess's law is concerned, there are two pieces of information that are very important and we can have a quick revision keeping in our mind this information. One information, always remember, according to Hess's law, whenever a chemical process takes place, every chemical process can involve two different paths. Every chemical process can be completed by using two different paths. One path is known as direct path and the other path is known as indirect path. Now what is the difference between direct path and indirect path? Direct path is a path when a reaction is completed using one step only. If a process is completed using one step only, it is known as direct path, and if ever a process is completed using more than one step, that is known as indirect path. So this is one simple information we must remember, that every chemical process, it can be completed using one step only, or there might be more than one steps. More than one steps can be either two steps, three steps, or four steps. Any number of steps greater than one will be considered as indirect path. This is one piece of information. Second information, whether we carry out a chemical reaction using direct path or indirect path, the total energy change, the total enthalpy change for that chemical reaction, it will remain unchanged. So what does this mean? Mathematically, we can remember that enthalpy change of the direct path, it is always equal to the enthalpy change of the indirect path. So it doesn't make any difference whether we complete a chemical reaction using direct path or using indirect path. The total energy change for that chemical reaction, it remains unchanged. Okay. After this, now we are going to take an example of a covalent compound like ethanoic acid, and we will write down thermochemical equations for the formation of ethanoic acid. Ethanoic acid is an organic liquid. Its chemical formula is CH3COOH. Now we are going to write down thermochemical equations for the formation of this compound, and we will write down thermochemical equations using both direct path and indirect path. Now what is the direct path? As I told you, simply you can prepare ethanoic acid in one step. How is that? If we look at ethanoic acid is a combination of three types of elements. What are the three types of elements that are involved in the formation of ethanoic acid? You can see one element is carbon. Carbon is a solid non-metal. Hydrogen is a diatomic gas. Oxygen is a diatomic gas. So you can see we can combine these three elements, and we can expect the formation of ethanoic acid. When we will mix these three elements and we will get ethanoic acid, this will be known as direct path for the formation of this compound, since it involves one step only. Now we will balance this equation, and for balancing, you can see on the right hand side we are having 1 mole of ethanoic acid. So to balance this equation for 1 mole of ethanoic acid, what we can do, we can use a coefficient of 2 mole of carbon on the left hand side, 2 mole of hydrogen on the left hand side, because there are 4 hydrogen in total on the right hand side, and number of oxygen, it is already balanced because 2 oxygen atoms are present on both sides. Now this is a simple balanced chemical equation. Now how you can change this balanced chemical equation, into a thermochemical equation? Whenever we want to make an equation, thermochemical equation, simply what we will have to do, we will have to introduce enthalpy change of that chemical reaction. Either the numerical value of enthalpy change or the label of the enthalpy change can be introduced to make this equation thermochemical equation. uh, like in this case you can see this is an example for the formation of ethanoic acid. So what does this mean? That we can remember, we can recall that this enthalpy change, whenever a compound is formed from its elements, it is known as enthalpy change of formation. So we can introduce the label of delta HF, enthalpy change of formation. So when we have introduced the enthalpy change label on this reaction arrow, now this reaction equation can be known as thermochemical equation. So now you got the difference. What is the difference between simple equation and thermochemical equation? Now this equation has become thermochemical equation and it is representing the direct path. Now let's write down equations, thermochemical equations for the formation of ethanoic acid using indirect path. What you must remember, whenever you are interested to write down equations for thermochemical equations for the formation of any covalent compound using indirect path, always remember it is a general fact that indirect path for the formation of any covalent compound involves two steps. How many steps? Two steps. One step is always the atomization. First of all, we have to atomize all the elements, and after atomization, those elements they take part in the formation of covalent bond. So two steps are atomization and formation of covalent bond. Let's start the indirect path, and you will see first of all we will atomize these elements one by one and we will introduce their enthalpy changes on the reaction arrow. Okay, let's atomize carbon. Atomization mean simply you will use the symbol of the element and the state symbol gas. This is atomization. Whatsoever is the initial state of that element, it does not make any difference. The final state must be gaseous state and the symbol of element. Also balance this, we will get 2 mole of carbon atoms. It is balanced now. Now atomize hydrogen. Atomization means H and the symbol gas, and there will be 4 atoms of hydrogen. So we will multiply it by 4 because there are 2 molecules of H2 before atomization. Now hydrogen has also been atomized. Now we will atomize oxygen. We will get 2 mole of oxygen atom because there is O2 molecule, and one O2 molecule contains 2 oxygen atom. Now you can see in this first step, we have in this first step of indirect path, we have atomized all the elements. Now this is a balanced equation for the atomization of all these elements. So what next we are going to do? We are going to convert this equation into thermochemical equation. How is that? Simply introduce the enthalpy change. For carbon, what the enthalpy change is known as? This enthalpy change, when gaseous atom is produced, it is known as atomization enthalpy. So you can write on atomization of carbon multiplied by 2. So this is enthalpy change of atomization of carbon multiplied by 2 because there are 2 mole of carbon. Likewise, you can write on enthalpy change of atomization of hydrogen multiplied by 4 because there are 4 mole of hydrogen. And for oxygen we can write on enthalpy change of atomization of oxygen multiplied by 2. So now this equation, the first step in the indirect path for the formation of covalent compound, this has also become thermochemical equation in this case. Now what will happen? These atoms, they are ready to react. When they will react, they will make covalent bond, and whenever covalent bond is formed, which enthalpy change is involved? Whenever a covalent bond is formed, the enthalpy change that is involved, it is known as bond energy or bond enthalpy. So we will draw an arrow from these gaseous atoms to the product. Here we will write down the bond energies, bond enthalpies. But before writing bond enthalpies, you must know the displayed structure, displayed formula of this compound, so that you can come to know that how many different types of covalent bonds are present in this compound. So for that purpose, you will have to write down displayed formula for the given covalent compound. I'm giving you the displayed formula for ethanoic acid. See, there is carbon bond, carbon having OH, carbon having double bond with oxygen, and this carbon that is in the beginning, it needs 3 more bonds. So it will make 3 more bonds, and these 3 bonds will be made with hydrogen. Now this is displayed formula of ethanoic acid. Now this displayed formula is very helpful in deciding how many enthalpy change, how many bond enthalpies, and what is the number of each bond enthalpy in the given compound, so that we can introduce the bond enthalpies on the reaction arrow. Okay, starting from the left hand side, look at the displayed formula. Starting from the left hand side, what you can see, what is the first bond, covalent bond, that is present in this compound? It is CH. And how many CH bond are present? 3. So what first bond enthalpy we will write down? We will write down bond enthalpy, bond energy of CH bond multiplied by 3, because there are 3 mole of CH covalent bond. So this is first bond enthalpy. Moving on from left to right, see which next bond comes, the bond of CC, carbon carbon. So we will introduce bond enthalpy of carbon carbon multiplied by 1, because there is 1 mole of carbon carbon. Move on, next bond is C double bond O. So bond enthalpy of C double bond O again multiplied by 1, because there is one double covalent bond between carbon and oxygen. Move on, single bond C and O, bond enthalpy of C single bond O multiplied by 1. And the final covalent bond that you can see in the given compound, it is OH, bond enthalpy of OH multiplied by 1. So whenever you are given a covalent compound, to write down bond enthalpies of in the last step, in the second step of the indirect path, you must know the displayed formula. If you will not write down the displayed formula, there are chances that you might make mistake, you might miss out some bond enthalpies of some covalent bond. So it is best, whenever you want to label bond enthalpies in the second step of the indirect path, you must have displayed formula in front of you, so that you can come to know how many covalent bonds are present in the given compound. Okay, now you can see we have written thermochemical equations using both direct and indirect path of Hess's law for the formation of this ethanoic acid. Now in the last, we are going to derive a formula. That formula can help us in solving numerical problems. Always remember, whenever you want to apply Hess's law on a covalent compound, first of all, for writing formula, you will have to identify, you will have to locate the initial stage and final stage. How to identify the initial and final stage? It is very simple. What is initial stage? It is a stage from where all the arrows they take a start, where arrows they touch their tails. That is the initial stage. And what is the final stage? Where all the arrows they end up, where all the arrows they end up, where all the arrows they touch their heads. Right now, what is the position from where both the arrows, you can see at each position two arrows are present, but what is the position, where is the stage at which we are having tails of two arrows? So you would have identified carbon, hydrogen and oxygen elements. If you look at both the arrows, one arrow is moving in the right direction and its tail is there at this rectangle that I have drawn, red rectangle, and an arrow is going downward, again its tail is there. And the final stage where the heads of both the arrows are present there, what is the final stage? The final stage is ethanoic acid liquid itself. Now you have identified initial and final stage. Now what that stage is known as, that is leftover. The leftover stage, which is neither initial stage nor final stage, it is known as intermediate. So that is intermediate, where there is one head, one tail. Okay, we will apply Hess's law, and I told you the second piece of information for the Hess's law, that enthalpy change of the direct path is equal to enthalpy change of the indirect path. How you will identify direct path? Now direct path is equal to minimum number of arrows. Where is the minimum number of arrows? Which one arrow is the resultant of the other two? So in this case, always remember, for the during the formation of covalent compound, the direct path always represented by the direct path, it is always represented by standard enthalpy change of formation. So this arrow is the resultant vector, resultant arrow. So mathematically, what you can write down, according to Hess's law, enthalpy change of direct path is equal to enthalpy change of indirect path. So what is the direct path now? Enthalpy change of direct path is formation of ethanoic acid, and it is equal to sum of enthalpy changes of indirect path. There are so many enthalpy changes in the indirect path. What we can write down? I am writing in a sequence. It is equal to atomization of carbon multiplied by 2 plus atomization of hydrogen multiplied by 4 plus atomization of oxygen multiplied by 2 plus bond enthalpy of carbon-carbon bond plus bond enthalpy of carbon-hydrogen bond plus bond enthalpy of C double bond O plus bond enthalpy of C single bond O and the final bond enthalpy of OH bond. So this direct enthalpy change, always remember, for the formation of covalent bond, direct path enthalpy change is standard enthalpy change of formation, and it is equal to enthalpy change of atomization plus bond enthalpy. So this is the formula that you can write down and you can do calculations. Now in this formula, you can, by using this formula, you can calculate enthalpy change of formation of a compound. Sometime enthalpy change of formation may be given, and you can be asked to find the enthalpy change for some other value. I hope you would have understood this lecture. If you have some problem, you can watch it again. Thank you for your time. Bye bye.